Hello, welcome to the January edition of the third grade mathematics parent video newsletter. This video will focus on the distributive property of multiplication, which is a strategy using products students know to solve for products they do not know. Students will use mental math to determine a product. This strategy will help build mastery of multiplication facts, which is the third grade fluency standard of 3.OA.5. Let's take a look at this problem. Mario has a rock collection. He has 8 rows of rocks in his storage container. Each row has 7 rocks. How many rocks does Mario have in his container? Students may choose to use a graphic organizer similar to the one you see here. In the box on the left, students will build an array based on the situation in the problem. Then they will take and split that array or decompose it into 2 separate arrays to find an equation or equations that will help them solve the problem easier. So in this problem, it says that Mario has 8 rows of rocks. So the first part of the problem, Mario has 8 rows of 7 rocks each. So students would begin by building an array that is 8 rows of 7. So 1, 2, 3, 4, 5, 6, 7. They would continue until they have 8 rows. Now you can see in the box on the left that I have an array that is 8 rows of 7. 1, 2, 3, 4, 5, 6, 7, 8 rows with 7 in each row. Now, when the students are solving these types of equations, 8 times 7 might be rather difficult for some third graders to answer. However, by using the distributive property, the students can decompose the array to build equations that they have fully mastered. Therefore, I'm going to take this 7 and I'm going to decompose the 7 into 2 and 5 because I know that 2 plus 5 equals 7. However, students may choose to decompose this in a different way, and that's okay. Now, when I'm decomposing this, I'm going to decompose my array so that I have 2 columns here, and I have 5 columns here. So now I have 8 rows of 5, 8 rows of 5, and I have 8 rows of 2. And as you've noticed, I've transferred my 8 rows of 5, my 8 times 5 equation, and my 8 times 2 equation to the right side of this graphic organizer. This way, students will be able to group these differently in order to solve for the equation 8 times 7. Now, the next step is to take these equations and build these arrays on this side of the screen. As students begin to build their array, they are also starting to think of rows and columns. I am going to, on the right side, draw 8 rows of 2. And on this side, draw 8 rows of 5. These represent the 8 times 5 and the 8 times 2. Again, this array here is representing this side of the array on that part of the screen. Now I have on this side 8 rows of 5. In previous grades, students have counted by 5s and counted by 2s. So it's natural for them to be able to solve this equation a lot easier than this equation over here, the 8 times 7. Now, the students might count by groups of 5, 8 groups of 5. So they might go 5, 10, 15, 20, 25, 30, 35, 40. So if this side has a total of 40, then they would count this side of the box. And they would count by 2s as they've done in second grade. 2, 4, 6, 8, 10, 12, 14, 16. Now, another way that students might be thinking about the groups of 2 is they might also be thinking of it as 2 groups of 8, because the commutative property helps them think of numbers flexibly. So therefore, they would be thinking about their doubles facts in 2 groups of 8. So these equations are a lot simpler for them to solve than 8 times 7. The final step in solving the equation 8 times 7 is to think about the products that I got from those equations that I knew. So I would add 40 plus 16 to get 56. So Mario would have had 56 rocks in his collection. I did this by thinking about the equation I did not know of 8 times 7 and distributing it into equations that I did know, 8 times 5 plus 8 times 2. Now, as students become more fluent in multiplication, they may not need to draw a model like we did here. They will take it to an abstract level and use an equation like is written on the bottom of this page. And they would write their unfamiliar equation and then think about how they personally would like to decompose it using the distributive property. So some students may choose to distribute and decompose this 8 into 4 and 4, or 5 and 3, and then multiply those things by 7. They may choose to take the 7 and decompose it into different ways, but that's what creates flexibility in the distributive property. Students solve for problems that they know. Using the equations that we already used for the model that we see, they would write the equation like this: 8 times 7 equals 8 times 5 plus 8 times 2 to get 56 rocks. Thank you for watching today's video newsletter on the distributive property of multiplication. If you enjoyed this video, be sure to hit that subscribe button and check back for more videos.